Hi students, I am your Nagini ma'am, chemistry mentor. In today's session, I am going to discuss about EZ nomenclature, organic chemistry, CIP rule students. Okay, now see here, the compounds which have the two identical groups students, which have two identical groups. See here, this compound butene 2, it is having the two identical groups CH3, CH3 here, CH3, CH3. This is cis former, this is trans former. Okay now, so these compounds are having two identical groups CH3 CH3. Yes, this compound is having two identical groups, two identical atoms, hydrogen hydrogen. Here also CH3 CH3, two identical groups are there. So the compounds which are having the two identical groups, those compounds are classified into two types, cis, trans, nana. Okay, the compounds which do not have two identical groups, understanding, so those compounds are classified into two categories. One is Z configuration and the one is E configuration. Clear students, this one difference understood? Cis, trans, where we have to apply students the compounds which have the two identical groups, understanding, those compounds are classified into cis, trans. The compounds which do not have two identical groups, understanding, which do not have two identical groups, those are classified into EZ configuration students. Understanding, two categories, one is Z configuration and the one is E configuration. Okay, so these two configuration students completely based on the atomic number ranking method, nana. Understanding, so Z letter came from the Latin word zusamen, meaning together. E configuration, E letter came from the Latin word entgegen. What is the meaning? Opposite, students. So coming to the definitions, nana, Z configuration. What is Z configuration? What is Z configuration? See here. If the higher atomic number groups are present same side of the doubly bonded carbon atoms, higher atomic number groups, okay, present same side of the doubly bonded carbon atoms, clear? Same side of the doubly bonded carbon atoms, higher atomic number groups present same side of the doubly bonded carbon atoms, that is calling as Z configuration. If the higher atomic number, understanding, higher atomic number groups are present opposite sides of the doubly bonded carbon atoms, opposite sides of the doubly bonded carbon atoms. Clear up? Opposite side of the doubly bonded carbon atoms there means a higher atomic number groups, that is E configuration students. Understanding, E configuration. Okay, now higher atomic number group same side there means that is Z configuration. Higher atomic number groups opposite side there means that is E configuration. Clear? Very easy topic students, you can easily understand. Okay, I will discuss in the examples, you can easily understand. Okay, now see here, Z configuration, E configuration. So this EZ nomenclature students introduced by this is Kahn, Ingold and Prelog students. Understand it? So this EZ nomenclature, this system is developed by Kahn, Ingold and Prelog. Okay, Kahn, Ingold and Prelog. So three members are, they developed this EZ nomenclature students. Understanding, Kahn, Ingold and Prelog. So that's in short form. Understanding. So this EZ rule is calling as CIP rule. Why we are calling CIP students? Understanding, because here in Kahn C first letter, Ingold first letter I, Prelog first letter P, CIP rule. That's why we are calling as CIP rule. This was introduced and developed by the Kahn, Ingold and Prelog. Clear this one? Kahn, Ingold and Prelog. Clear? So cis, trans, when we have to say students, the compounds which have the two identical groups, those are classified into cis, trans. The compounds which do not have the two identical groups, take here one example students, you can understand. See here, example C, double bond C, bromine, chlorine, next hydrogen, next here you take iodine. Okay, Now see here, two identical, here see this example, identical groups are there, CH3, hydrogen, two identical groups are there. Yes, but here identical groups are there, two identical groups are there, all are different groups are there, understanding? So in this case, here such type of compounds are classified into two categories, EZ configurations. Clear, students? Understanding? Now how to write E configuration and Z configuration, I will discuss in the example, students. You can easily understand. Clear? So the compounds which have the two identical groups, students, two identical groups, so those compounds are classified into cis and trans. The compounds which do not have two identical groups, understanding, which do not have two identical groups, those compounds are classified into two categories, E configuration, Z configuration, E configuration. Z letter came from the Latin word "zusum" and together it is antigen opposite. If the higher atomic number groups present same side of the doubly bonded carbon atom, that is Z configuration. If the higher atomic number groups are present opposite sides of the doubly bonded carbon atom, that is E configuration. Clear? So this rule was developed by Ingold and Prelog, that's it is calling as CIP rule. Clear? CIP rule. Now see, we will discuss the example. See, students. See here, first example. So here two atoms are there, chlorine, hydrogen. These two atoms attached to this carbon. Okay, now when your higher atomic number ranking method now, so what is the higher atomic number ranking method? See here, students. First to this carbon, which atoms attached to chlorine, hydrogen attached. In these two atoms, which is having more atomic number? Chlorine kada? Higher atomic number chlorine. So right here, this is higher atomic number atom, this is lower atomic number. This side completed. Now this side you write bromine, fluorine. You have to compare these two atoms. Here also you have to compare these two. Are you following? This side you should compare. These atoms you should compare this side. Okay, bromine, fluorine. Which is having more atomic number? Bromine. Fluorine is having lower atomic number. Now see here, what I told Z configuration. If the higher atomic number groups are present same side of the doubly bonded carbon atoms, same side there. Same side there, chlorine, bromine, higher atomic number atoms present same side of the doubly bonded carbon atoms. Clear? So this is calling as which configuration? Z configuration. Clear, students? This is Z. Next example, see here. Next example, see. These two atoms, which is having more atomic number? Bromine, chlorine, bromine kada. This is higher, this is lower. Now this one, tell me here. This carbon is attached to carbon, here hydrogen. Here group is there. These are all atoms. We can easily understand which is having more atomic number. But here what is there? Methyl group is there. Here hydrogen is there. Now you have to see. This carbon is attached to this carbon. Here in methyl group CH3, what is the first atom is there? That you have to consider. In methyl group carbon is there, first atom. Here which atom? Hydrogen. Understanding? You have to consider carbon, first atom. Okay. Here hydrogen is there. Hydrogen, carbon and hydrogen, which is having more atomic number? Carbon kada. So that's why it is having higher atomic number. This is lower atomic number. Now you see, students, higher present same side of the doubly bonded carbon atoms. That's why it is which configuration? Z configuration. Clear? This is Z configuration. Okay. Now see, students, third example. Third example, see here. Third one. Bromine, chlorine, this side. Which is having more atomic number? Bromine. First priority. This is higher atomic number group. This is lower atomic number group. Understanding? This side completed. Now this side you tell me. This side. This carbon is attached to CH3. Here ethyl group. Now see here, students. It is attached to carbon, here also carbon. Okay, in this example, carbon or hydrogen, it is higher atomic number, we can easily identify. But here carbon, here also carbon there. Understanding? Then, to this carbon, which atoms attached? This carbon, which atoms attached? That you have to write. CH3 means what, Nana? 3 hydrogens attached. Correct? CH3 means 3 hydrogens attached to the carbon. Okay, the 3 hydrogens you write like this. 3 hydrogens are there, right here. Next, CH2, CH3. That means to this carbon you have to take. This carbon To this carbon, which atoms attached? H2. See, H2 means C, hydrogen, hydrogen. H2. This is CH3. Write as it is. Now see here students. To this carbon, which atoms attached? Carbon attached, hydrogen attached, hydrogen attached. So here atomic number increase, atomic number which is having more, carbon, hydrogen, hydrogen, carbon. That atom first you write. Carbon, carbon, hydrogen, hydrogen. So what are the three atoms attached to this carbon? That you should write. What are the three atoms attached to this carbon? 3 hydrogens. Here to this carbon, which atoms attached to this carbon? 1 carbon or 2 hydrogens attached. Right here. Now these three atoms you have to compare. First atom hydrogen, here first atom carbon. So that's if it is the higher atomic number carbon. So it is the higher atomic number group. Clear? So this is higher, this is lower. Now you observe students, higher atomic number groups are present opposite sides of the doubly bonded carbon atom. So that's it is which configuration? E configuration. Clear? E configuration. Understanding students? E configuration. I told you already. Higher atomic number groups. Understanding? Higher atomic number groups. Higher atomic number groups are present same side of the doubly bonded carbon atoms. That is Z configuration. Understanding? Okay. Just to remember this trick students. Here I am writing. Here on I will give you trick box. See here. Trick. Higher atomic number groups. Okay, higher atomic number groups same side to the doubly bonded carbon atom. Same side there means that is Z configuration. Clear? Z configuration. Next one, higher atomic number groups present opposite sides to the doubly bonded carbon atom. That is E configuration. Clear students? E configuration. Just you keep in your mind this trick box. Enough. Okay? Understood? Clear? Higher atomic number groups same side there means that is Z configuration. Opposite sides there means E configuration. Clear? Now see, do this all examples students. See next example. See double bond C, bromine, here see. Here bromine, 2 identical atoms attached to the carbon. So that's it does not exhibit geometrical isomerism. Understanding geometrical isomerism not possible. Does not exhibit. Next one see here. C double bond C, hydrogen, chlorine, bromine, hydrogen. See here higher atomic number. These 2 atoms which is higher. Chlorine is higher atomic number atom. Hydrogen atomic number 1 it is lower when compared to this. Now this 2. In this 2 which is having more atomic number? Bromine. Hydrogen lower. Understanding? Bromine higher, hydrogen lower. Now see higher atomic number groups where there? Opposite sides are there. Are you following? Opposite sides. That's it is which configuration? E configuration. Clear? E configuration. Next example see. C double bond C. Now see here. Deuterium. D means deuterium, hydrogen, which is having more atomic number students. Here you have to consider first in the atomic number ranking method students. Here hydrogen isotopes are students. Protium, deuterium, tritium. So first priority we should give for the tritium, next deuterium, next hydrogen. So that's why we have to consider this one as higher atomic number group. Clear? So this is lower atomic number. This side completed. Now this side. Here this carbon is attached to carbon. Here carbon, here hydrogen. Now you tell me which is having more higher atomic number? This one. This is lower. Clear? Higher where there? Same side of the doubly bonded carbon atom. So that's it is which configuration students? Same side there means Z configuration. Clear? Z configuration. Over. Now see here. Next example see. C double bond C, CH2OH. Now here in these 2 groups which is having more atomic number? Bromine higher, H it is lower. This one completed. Now this one see. This carbon is attached to carbon. Here also carbon. Now this carbon is attached to which 3 atoms? This carbon is attached to which 3 atoms that you write. Here see, this carbon is attached to 2 hydrogens and 1 carbon. Correct now? CH2, CH. Understand it? This one I am writing separately. See here. CH2, CH2. Okay. CH2, OH. Now see, this carbon is attached to, means this one. This carbon is attached to which atom, students? This carbon, this one. It is attached to which atoms? Carbon, 2 hydrogens. That right here, that right atoms, carbon, 2 hydrogens. Okay. Now this carbon, you see, this carbon is attached to which atoms? This carbon, CH, CH3 twice. Write separately here. CH, this bond, CH, CH3 twice. Means 2 methyl groups are attached to carbon. CH3 twice. Here one CH3, here one more CH3. Now tell me, to this carbon is attached to which atoms? This carbon. It is attached to which atoms? Carbon, carbon, hydrogen. Clear? Carbon, carbon, hydrogen. Understanding, students? Carbon, carbon, hydrogen. Clear? Carbon. Carbon is attached to this carbon. This carbon is attached to this carbon. Hydrogen is attached to carbon. So atomic number which is more carbon, na? So that atom first you write. Carbon, carbon, hydrogen. Tell me. Here first atom carbon, here first atom carbon. Same atoms are there. Then go for second atom. Here hydrogen, here carbon there. It is having the more atomic number. That's it is the higher atomic number group. This is the lower atomic number group. Clear? So like this you have to calculate, students. So higher both are how they are? Opposite sides are there. So opposite sides are there means what we have to call? Opposite sides there means E configuration. Okay. E configuration. Now see this example. C double bond C CHO. Here this carbon is attached to carbon. Here this carbon is attached to nitrogen. Here carbon, these atoms you have to consider. Only first atom. Carbon, nitrogen, which is having more atomic number, nitrogen kada. So first this is higher atomic number group. This is lower atomic number group. Now here this carbon is attached to carbon, here oxygen. So here oxygen, here carbon, which is having more atomic number. Different atoms are there now. So oxygen, carbon, only first atom you have to say, you have to take. Oxygen, carbon, it is having the higher atomic number. Carbon is having lower atomic number. Now higher where there? Same side of the doubly bonded carbon atom. Same side there. That's it is which configuration? Same side means Z configuration. Clear? Z configuration. Understanding? Right. Z configuration. Now see, students, another example. Another example. Here see. Bromine, chlorine. Higher atomic number bromine, lower atomic number chlorine. See here this carbon is attached to carbon, here also carbon. So to this carbon which atoms attached? 3 atoms which are attached. CH2OH. I am writing this one CH2OH like this. CH2, okay, OH. Now tell me, to this carbon which atoms attached? Oxygen, 2 hydrogens. Correct? Oxygen, 2 hydrogens. Write that 3 atoms here. Okay. Clear? Now see, CCH3 thrice. This one also you write separately. CCH3 thrice. This one single bond C. 3 methyl groups attached. Here 1 methyl, 2 methyl, 3 methyl. Now tell me, to this carbon, which atoms attached to this carbon? Carbon, carbon, carbon. This hydrogen is attached to this carbon. Okay. To this carbon, 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 3 carbons attached. So write that 3 carbons here. Now you observe. Here first atom oxygen, here first atom carbon, which is having more atomic number. Oxygen, so that's it is higher atomic number group. This is lower atomic number. Now higher where there? Where there? Same side there. So that's why it is calling as Z configuration. Clear? Z configuration. Understood? Z configuration. Now see here this example. Bromine, chlorine, which is having more atomic number? Bromine. So this is higher, this is lower. Clear? Now coming to here, CH2OH, C double bond OH. C double bond OH, students. CH2OH, how to write it? CH2. Two hydrogens attached. OH. CH2OH. That means to this carbon, which atoms attached to? Oxygen, hydrogen, hydrogen. So write that three atoms, oxygen, hydrogen, hydrogen. Clear? Oxygen, hydrogen, hydrogen. Now see this one, C double bond OH. You see students, CHO, C double bond O, C double bond OH. This group we can write it as it is equals to okay, C, CH, okay, double bond O, we can write it as single bond O, single bond. Double bond O is there. We have to separate this one. That means double bond O, it is equals to two oxygens, two oxygen atoms. We have to write like this. C double bond O H, it is equals to C single bond O, single bond. That means double bond we have to separate. Single bond O, single bond O. Okay now. Now see here one more. It is also equals to, see here, C triple bond N is there. C triple bond N. Suppose the group is there. C triple bond N. It is equals to students single bond C triple bond N. Triple bond means single bond N, single bond N, single bond N. That means this carbon is linked with three nitrogens. This carbon is linked with two oxygens. Are you following? So in case of double bonds, triple bonds, you have to write like this, students. Understanding? Now see here, C double bond OH. That means it is this carbon is attached to which atoms? So oxygen, oxygen, hydrogen. Kada? Two oxygens. See here, two oxygens, so one hydrogen. Clear? So here first oxygen, here first oxygen. Then go for second atom, hydrogen, oxygen. So this is higher atomic number group, this is lower. Now higher, where there? Opposite sides are there. So that's why this compound is which configuration? E configuration. Clear? E configuration. Now see next example, students. See this one. Here, this carbon is attached to carbon, here attached to nitrogen. This is carbon, this is nitrogen. So which is having the more higher atomic number, students? Carbon or nitrogen? Nitrogen kada. So this is higher, this is lower. Clear? Now see here, this is attached to iodine, bromine. Which is having more atomic number? Which one? Iodine kada. Higher, this is lower. Clear? Now higher, where there? Opposite sides are there. Opposite sides there means to the doubly bonded carbon atoms, that is E configuration. Clear? E configuration. Now see this example. C double bond C chlorine OH. See here, chlorine, no, here carbon is attached to chlorine atom, this carbon is attached to oxygen. Which is having more atomic number? Chlorine na oxygen na? Chlorine kada. So higher atomic number is this one, this is lower. Here this carbon is attached to carbon, here iodine. So which is having more atomic number? Iodine. So this is higher, this is lower. Now higher, where there? Opposite sides are there. Higher atomic number groups. That's why it is opposite side there means E configuration. Clear? E configuration, students. Next one. See this last example. Last example, see here. C double bond C, this carbon is attached to nitrogen, here carbon. Which is having more atomic number? First atom you have to see in that group, first atoms. Different atoms are there means directly we can write. If suppose same atoms are there, carbon, to that carbon which three atoms attached to this carbon, which three atoms attached, that you have to follow. Nitrogen, carbon. So nitrogen is having the more atomic number, so it is higher atomic number group. This is lower atomic number group. Now coming to here, carbon is attached to sulfur. Here this carbon is attached to oxygen. Sulfur more, oxygen more atomic number, sulfur more. That's why it is higher, it is lower atomic number group. Clear up? So higher, both are present same side of the doubly bonded carbon atom, same side there. So that's why it is which configuration? Z configuration. Clear up? Z configuration. Clear, students? I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel. Thank you students.